Ancient, untamable, boundless, alive. The Atlantic Ocean does not divide the planet. It connects it. Stretching from the Arctic ice of Greenland to the Antarctic shelves, it covers 1/5 of the Earth's surface. 106 million years ago, none of this existed, only a scorching rift in the single supercontinent of Pangaea. Since then, that rift has never stopped widening. Slowly, at the pace of a growing fingernail, the ocean pushes its shores apart. And it is doing so today, right now. Its surface area spans more than 106 million square kilometers, a space large enough to swallow North America, South America, and Europe combined, and still have room to spare. Deep within its heart, beneath 3 kilometers of dark water, lies the Mid-Atlantic Ridge, a mountain chain 16,000 kilometers long, the invisible spine of the planet. Here, in the Rift Valley, new ocean floor is born, pressed upward from the Earth's interior, in absolute silence and absolute darkness. The Gulf Stream carries the warmth of the tropics to the shores of Scandinavia, heating an entire continent. The cold Labrador Current draws nutrients up from the abyssal depths, feeding fishing grounds that have sustained humanity for millennia. These waters do not stand still. They move in a ceaseless rhythm, like blood through a circulatory system. Each cycle takes 1,000 years, each cycle without pause. The largest animals ever to have existed on Earth live here. Life forms for which sunlight is nothing more than an abstraction hide here. Here, every species is not a separate story, but a thread in a vast and invisible fabric. The Atlantic is not a backdrop for life. It is life itself, and this story is only just beginning. Welcome to the Planet Instinct channel. Put the kettle on. Drop a comment telling us where in the world you're watching from. And let's dive into an extraordinary journey. Imagine a force invisible from the shore. No sound, no splash, only the unstoppable movement of billions of tons of water in a single direction. No sign, no boundary, nothing to betray its presence. Only a barely perceptible shift in the color of the water. A little darker, a little bluer, a little warmer. This is the Gulf Stream, and it changes everything. The Gulf Stream is not merely a current. It is a conveyor belt of heat that encircles half the planet. A system without which London would feel like Moscow, Oslo would become an Arctic wasteland, and the vineyards of France would remain nothing more than a dream. It carries more water than all the world's rivers combined, multiplied 100-fold. Its width spans 80 kilometers. Off the coast of Florida, it moves at nearly 10 kilometers per hour. It flows with such relentless persistence that for centuries, sailors used it as a free engine. Traveling north with the Gulf Stream was faster than sailing under canvas. It is born in the tropics. In the warm, sun-soaked waters of the Caribbean Sea and the Gulf of Mexico, the surface layer heats to 30 degrees and begins its journey northward, driven by pressure differences and the rotation of the Earth. The Gulf Stream rounds Cape Hatteras, breaks away from the North American coastline, and surges across the open ocean toward Europe, gradually cooling and splitting into branches. One arm washes the shores of Scandinavia, another flows into the North Sea, and a third curves back and begins the return journey, now as a cold, deep current running along the floor of the Atlantic. It is precisely where the warm waters of the Gulf Stream meet the cold masses of the Labrador Current that an invisible boundary forms, one of the most productive ecological zones on the planet. Cold water, rich in nutrients drawn up from the depths. Warm water, rich in light and heat. Where they collide, they create conditions in which phytoplankton multiplies at extraordinary speed. The Grand Banks of Newfoundland, shallow plateaus to the south of the island, became one of the richest fishing grounds in human history because of this collision of two worlds. For 5 centuries, European fishermen crossed the Atlantic for these waters. Cod was so abundant here that, according to the first colonists, you could scoop it up in a basket. Through these waters moves a creature that knows the Atlantic as no other does. The Atlantic bluefin tuna is the embodiment of speed and endurance in equal measure. Its body, refined by 30 million years of evolution, has achieved a level of hydrodynamic perfection that modern engineers study when designing torpedoes and underwater vehicles. Why change when you are already perfect? Its dark blue back merges with the deep water when viewed from above. Its silver belly dissolves into the diffuse light of the sky when viewed from below. It is invisible from both directions. Perfect camouflage in a world without cover. It can weigh up to 700 kilograms, yet accelerates to 70 kilometers per hour, faster than most land predators. In the water, amid shoals of mackerel or herring, it does not chase its prey. It intercepts it before the prey has time to register what is happening. But its defining quality is not speed. The Atlantic bluefin tuna is a warm-blooded fish. Its body temperature runs several degrees higher than the surrounding water, sustained by a specialized heat exchange system. A network of blood vessels that retains warmth within the muscles. This means its muscles fire faster, its brain reacts more sharply, its responses outpace everything else in the cold water around it. It can dive to 600 meters and return to the warm surface immediately, moving between temperature zones with an ease that confounds physiologists. The Atlantic bluefin tuna is not simply a predator. It is an architect of balance in the upper layers of the ocean. By regulating the populations of mackerel, sardine, herring, and squid, it prevents any single species from overwhelming the ecosystem. Its migrations span the entire Atlantic. It spawns in the warm waters of the Mediterranean and the Gulf of Mexico, and feeds in the cold, productive waters of the north, carrying energy accumulated across thousands of kilometers within a single body. It is a living bridge between the tropics and the poles. Without it, the upper layers of the Atlantic would descend into the chaos of unchecked population explosions. Mid-level fish would graze zooplankton to exhaustion. Zooplankton, in turn, would lose its grip on phytoplankton, and without the balance of phytoplankton, without those cells invisible to the naked eye, responsible for half of all the oxygen on the planet, the composition of the atmosphere begins to shift. The tuna pulls a thread, and that thread reaches into the very air we breathe. But where the tuna moves, something else moves too, something for which the tuna is merely one option among many. In the blue of the open water, at the point where the Gulf Stream begins its crossing of the open ocean, a shadow takes shape, long, unhurried, without urgency. It is in no rush. It has no reason to be. 400 million years. That number is difficult to hold in the mind. When the first sharks appeared, there was not a single tree on Earth. No birds, no dinosaurs, no mammals. the first fish were only beginning to venture onto land, the continents lay in entirely different positions. Since then, the planet has survived 5 mass extinctions, each of which wiped out the majority of existing species. Sharks survived them all. Not merely survived, they remained unchanged. Nature had no need to revise them. The great white shark moves through water the way it moves through time, without visible effort, without hesitation, with the absolute confidence of a creature that has no natural enemies. Its body, up to 6 meters long, cleaves the water with minimal resistance. Its skin is covered in dermal denticles, tiny, tooth-shaped scales aligned with the direction of water flow. They do not merely reduce drag, they generate microvortices that draw water along the body, providing additional thrust. Modern engineers replicate this principle in the surface coatings of Olympic swimsuits. 1,000,000 years of natural engineering in every square centimeter of skin. Its sensory system is unmatched among vertebrates. The lateral line, a canal running the length of its body, detects vibrations and pressure changes in the water. It senses the movement of a wounded fish half a kilometer away. Its nostrils can detect a single drop of blood in a volume of water the size of an Olympic swimming pool. But most remarkable of all are the ampullae of Lorenzini, hundreds of tiny pores on the snout filled with conductive gel. They detect the faintest electrical fields, the bioelectrical activity of the muscles and heart of any living creature in the water. Every animal generates an electrical field. For the great white shark, the ocean is not darkness. It is a luminous map of life. The great white shark hunts differently from most predators. It does not chase its prey. It studies it. It can circle for hours in the depths below a seal colony, watching. It selects the weakened, the careless, the one that has strayed from the group. Only then comes the attack, vertical from below, accelerating a 600-kilogram body to 25 kilometers per hour in seconds. The impact is so powerful that the prey is frequently launched into the air. But the great white shark is not only a killer, it is a regulator. Its mere presence, even without a single hunt, alters the behavior of hundreds of surrounding species. Scientists call this the landscape of fear. Seals know which zones are dangerous and avoid them. This means that the sea urchins on which seals feed in safer areas are left undisturbed. Sea urchins, in turn, keep algae growth in check. Without them, kelp forest would spread without limit. Every behavioral decision a seal makes out of fear of the shark ripples through the entire food web. Wherever sharks were hunted to near extinction, along the U.S. East Coast in the mid-20th century, in the Mediterranean, along stretches of the Atlantic shelf, ecosystems were transformed beyond recognition. Ray populations and other cartilaginous fish exploded without regulation. Rays consumed bivalve mollusks to the point of collapse. Oyster beds that had existed for centuries vanished within a few years. Fishing grounds fell apart. All of it began with the disappearance of the shark, a creature that did nothing more than swim nearby and occasionally hunt. The evolutionary wisdom of the great white shark lies not in strength or speed. It lies in the fact that its presence alone is an ecological instrument. It governs without intervening. It shapes without building. It holds in balance a system in which hundreds of thousands of species find their place, because they know where their freedom ends. its pectoral fins. Wide, unhurried, rise and fall in a rhythm unchanged for 400 million years. It descends into the depths, to where the blue darkens to black, to where its territory ends, and something else begins, something for which pressure is not a threat, but a condition of existence. 8,000 meters beneath the waves of the Atlantic, in absolute darkness, in a place no human foot has ever touched, where no ray of light has ever reached and never will, the planet breathes, slowly, continuously, with an effort impossible to measure, yet felt across every surface of the Earth above. The Mid-Atlantic Ridge is the longest mountain chain on the planet. 16,000 kilometers of continuous underwater massif, stretching from the Arctic to the Antarctic, running precisely through the center of the Atlantic Ocean. If the waters were to recede, a mountain system would be revealed beside which the Himalayas would look like foothills. The peaks of the ridge rise 3 kilometers above the average level of the ocean floor. Yet even they remain hidden under kilometers of water. Only a handful of summits breach the surface, forming the islands of the Azores, Ascension Island, and St. Helena. Here, in the Rift Valley, a canyon several kilometers wide running the entire length of the ridge, the North American Plate and the Eurasian Plate drift apart by 2.5 centimeters every year, the speed of a growing fingernail. It sounds insignificant until you multiply it by 100 million years. This is how, from nothing, the Atlantic Ocean formed. This is how it continues to grow today, and it will keep growing until it has consumed the Pacific. From the cracks in the ocean floor erupt hydrothermal vents, black smokers. Water that has seeped down through fissures in the rock is heated to 400 degrees Celsius and blasts back upward under pressure, saturated with hydrogen sulfide, manganese, iron, and copper. Where this boiling solution meets the cold bottom water, minerals crystallize instantly and settle, building conical towers up to 20 meters tall. They billow black clouds into the darkness, like the chimneys of an underground factory that has been running since the birth of the Earth. No sun, no photosynthesis, nothing that, by any known law, should sustain life. And yet, life here is rampant. Chemosynthetic bacteria convert hydrogen sulfide into organic matter, building the foundation of a food chain without a single photon of light. This discovery, made in 1977 off the Galapagos, overturned biology. It turned out that life does not need the sun. It needs only energy, in whatever form is available. Around the black smokers of the Mid-Atlantic Ridge, live creatures that nature invented from scratch, with no template, no precedent. Giant tube worms, Riftia pachyptila, grow up to 2 meters in length. They have no mouth, no stomach, no digestive system in any conventional sense. Inside their bodies live billions of chemosynthetic bacteria, converting hydrogen sulfide into organic matter directly within the tissues of the host. The worm is a living reactor, a creature whose symbionts have replaced digestion entirely. This is not parasitism and not a chance arrangement. It is a new form of life. Moving alongside them, a blind shrimp, Rimicaris exoculata. Their eyes have atrophied, but in their place, light-sensitive organs have developed on their backs, responsive to the faint infrared radiation of the hot water. They do not sense light. They sense heat. This allows them to remain as close as possible to the hydrothermal vents, where bacterial concentrations are highest without being boiled alive. The margin between comfort and death for them is a matter of centimeters. Yeti crabs, octopuses with tissues resistant to hydrogen sulfide, fish with slowed metabolisms that allow them to exist virtually motionless under 300 atmospheres of pressure. Each species here is a separate evolutionary experiment conducted by nature in conditions of total isolation from the rest of the world. The hydrothermal vents of the Atlantic are not merely an ecosystem. They are proof of a principle that rewrote astrobiology. If life is possible here, in a lightless hell, under pressures and temperatures that destroy most organic molecules, then life is possible anywhere there is liquid water and chemical energy. Beneath the ice of Europa, moon of Jupiter, lies a warm interior ocean. On Enceladus, moon of Saturn, geysers erupt through the ice from below. Looking at the black smokers of the Atlantic, scientists do not simply see the ocean floor, they see a blueprint for possible life across the universe. The ridge stretches northward, toward where cold becomes a wall, where water takes on properties that make the impossible ordinary. At the very center of the North Atlantic, roughly where a meridian connects the Bermuda Islands to the Azores, lies a place unlike anywhere else on the planet, a sea without shores, bounded not by land, but by currents. The Gulf Stream to the west, the North Atlantic Current to the north, the Canary Current to the east, the North Equatorial Current to the south. 4 great oceanic conveyors have closed into a ring, and sealed within it a still, near motionless, separate world, the Sargasso Sea. For centuries, this place terrified sailors. Calm water in the heart of the Atlantic felt like a trap. Legends spoke of ships permanently ensnared in weed, condemned to circle forever. Columbus, in his journals, describes the anxiety of his crew at the sight of green carpets spreading across the open ocean. In reality, the seaweed is not dense enough to halt a vessel, but the psychological effect was very real. The surface of the Sargasso Sea is covered in freely drifting brown algae, sargassum. Unattached to the ocean floor, it forms floating islands ranging from a few square meters to several hectares. These are the only seaweeds in the world to complete their entire life cycle in the open ocean, never once touching a shore or the seabed. Air-filled bladders, pneumatocysts, keep them buoyant, creating floating platforms that neither sink nor drift in a single direction, but slowly rotate with the circular currents. Within these underwater jungles lives a community found nowhere else on Earth. The sargassum fish, histrio, does not look like a fish. Its body is covered in flaps and filaments that perfectly mimic the shape and color of sargassum fronds. Its fins have become something resembling hands. It literally walks through the weed, gripping as it goes. Its mouth snaps open in a fraction of a second, creating a vacuum that pulls in prey before it can react. This creature has adapted so completely to the sargassum that it cannot survive without it. Young loggerhead turtles, caretta, hatch on Atlantic beaches in Florida and the Caribbean, and instinctively head out into the open ocean. No one taught them this. No one showed them the way. They navigate to the Sargasso Sea on their own, guided by a magnetic sense that reads the Earth's field with the precision of a navigation instrument. Here, sheltered within the floating mats of weed, they spend the first years of their lives. Invisible to most predators, hidden in green labyrinths, This period is known as the lost years of the loggerhead turtle. For a long time, scientists had no idea where hatchlings disappeared to after leaving the beach. The Sargassum was their refuge. But the greatest secret of the Sargasso Sea is one, the European eel, kept for millennia. For centuries, fishermen caught eels in the rivers and lakes of Europe, fat, mature, fully grown. But no one had ever seen an eel's egg. No one had ever seen an eel larvae. No one knew how they reproduced. Aristotle believed eels were spontaneously generated from river mud. In medieval Europe, this was accepted as fact. Only in the early 20th century did the Danish biologist Johannes Schmidt methodically comb the Atlantic, measuring eel larvae, leptocephaly, and moving toward ever smaller specimens. The trail led him to the Sargasso Sea. Each autumn, mature eels leave the rivers and lakes of Europe and America. They stop eating. Their eyes enlarge, adapting to the darkness of the deep. Their bodies accumulate fat, the only fuel for a journey of 3,000 kilometers, non-stop and without food. They cross the Atlantic, descend to depths of several hundred meters above the Sargasso Sea, spawn, and die. Their larvae, transparent as glass, rise to the surface and drift eastward with the Gulf Stream for 2 to 3 years. On reaching European shores, they transform into glass eels and enter the rivers. The cycle closes. The Sargasso Sea is not merely an ecosystem, it is a crossroads, a hub connecting the freshwater rivers of Europe with the middle of the Atlantic. Without it, the eel will vanish. Without the eel, river ecosystems will collapse from Spain to Scandinavia. The eel is a keystone predator of the benthic layer in most European rivers. The thread stretching from a German river to the Sargasso is one of the longest and most invisible threads in nature. To the north of the quiet Sargasso, the Atlantic changes character. The sky darkens, the wind builds, the water grows colder with every degree of latitude. There, where day lasts half a year and night the other half, life has found ways to turn extremity into advantage. The North Atlantic in winter is a trial with few equals on the surface of the planet. Winds at 100 kilometers per hour shear the crests of waves and scatter them into white foam that flies horizontally. Air temperatures drop to 20 below zero. 20-meter waves are not the exception. They are the norm. Fishing vessels have vanished here without trace. Oil platforms have lost equipment in a single storm night. This is a place where humanity arrived last and leaves first. Yet it is precisely this brutality that creates the conditions that govern the climate of the entire Northern Hemisphere. Winter winds chill the surface waters of the North Atlantic to their limit. Cold, dense, salt-laden water is heavier than warm water. It sinks, not a slow drift. It falls, plunging to depths of 2 to 3 kilometers in a relatively short span. And then begins a slow southward journey. Along the Atlantic floor, toward the equator, curving around it and continuing into the Indian and Pacific Oceans. There, after centuries, it slowly rises again, warming and returns northward along the surface. One complete cycle of this global conveyor belt takes 1,000 years. This phenomenon, the Atlantic meridional overturning circulation, is one of the planet's primary thermostats. It carries tropical heat toward the poles. It drives nutrients from the ocean floor to the surface. It regulates the concentration of carbon dioxide in the atmosphere. Should this circulation weaken, and modern measurements show it has already slowed compared to the mid-20th century. The climate of Europe will change rapidly and irreversibly. Britain, at the same latitude, would begin to resemble Labrador climatically. Winters would lengthen. Monsoons would shift. The savannas of West Africa would dry out. In these waters, amid the storms and the spray, with the absolute composure of a creature for which a storm is not a threat, but simply an ordinary environment, the humpback whale feeds. Its appearance at the surface is a sight that defies description. A body 15 meters long and 30 tons in weight rises from the water in a slow, arching leap, and crashes back down with a boom and an eruption of white water, audible kilometers away. Breaching the full launch from the water, humpbacks perform again and again, sometimes for hours. Why? Scientists still disagree. Long-distance communication, dislodging whale lice, a display of strength, or perhaps simply because they can. The songs of the humpback whale are among the most complex acoustic phenomena in nature. Males sing without pause for hours, continuously evolving and elaborating their melodies. All males within a single ocean basin sing the same version of a song, and it changes collectively, like a living culture. New phrases coined by one male are taken up by others and spread across thousands of kilometers of ocean faster than chance alone could explain. This is not instinct. This is learning. This is culture. The humpback whale feeds by a method with no precise parallel in nature. Bubble net feeding is a complex cooperative hunt requiring coordination, learning, and what appears to be a division of roles. A group of several whales dives beneath a dense shoal of herring or capelin. One or more begin to circle, exhaling through their blowholes. The bubbles rise in a cylindrical curtain, a kind of net. The fish instinctively refuse to cross this barrier, compressing into a tight ball. At that moment, the whales surge upward from below with open mouths, and each lunge yields tons of food. This technique is passed on to calves. Individual groups have developed their own variations. This is hunting with a tradition. But the humpback whale is not only a hunter and a singer, it is a pump. Its excrement, rich in iron and nitrogen, rises to the surface in clouds of nutrients that stimulate the growth of phytoplankton. A single whale produces enough nutrients in a year to sustain the growth of plankton that locks away thousands of tons of carbon. When a whale dies, its body sinking to the sea floor, it feeds deep-sea communities for decades. Scientists call this slow gift a whale fall, one of the most important mechanisms for transferring carbon from the atmosphere into the ocean depths. The whale does not merely live in the Atlantic, it participates in the Atlantic's breathing. From the polar storms, we descend to where storms never reach, where in place of fury, absolute silence, where pressure of hundreds of atmospheres is not an obstacle, but a condition of life. At a depth of 1,000 meters, sunlight does not exist. It has never been here. Not a single photon in all the time this water has occupied this place, and that is centuries. The temperature is around 2 degrees above zero. The pressure is 100 atmospheres. There is no cycle of day and night, no seasons, nothing but an endless, unvarying, absolute darkness and movement, because this abyss is not dead. It is full. The deep scattering layer, the daily vertical migration, is one of the most vast daily events on the planet and one of the least known. Every evening, with the onset of darkness, hundreds of billions of creatures rise from the depths toward the surface. Zooplankton, small crustaceans, small fish, squid. For a few hours they feed in the phytoplankton-rich surface waters, and at dawn they descend again into the protective darkness, away from predators that see in the light. This vertical pendulum, 200 meters up at night, 200 meters down by day, is one of the primary mechanisms by which carbon is transferred from the surface into the depths. Creatures absorb carbon at the top and release it in the form of waste below. Billions of small bodies every single day carry carbon to the bottom. Through this world moves the sperm whale, the largest toothed predator on Earth. A male can reach 20 meters in length and 50 tons in weight. And every 2 hours, it dives into the abyss. Its body withstands pressure that would crush most metal structures. Its lungs, filled with air before the dive, collapse under pressure. This is not catastrophe, but salvation. Collapse prevents nitrogen narcosis, which would be fatal to any human diver. The sperm whale's blood contains 8 times more myoglobin than human blood, meaning its muscles hold a colossal reserve of oxygen. The heartbeat slows. Blood flow is redirected to the brain and heart. Non-essential organs shut down. It remains submerged for up to 90 minutes. It hunts the giant squid, a creature that humanity knew for centuries only through indirect evidence. 3-meter tentacles recovered from the stomachs of sperm whales, sucker rings 10 centimeters in diameter that left scars in the whale's skin. The first authenticated photograph of a living giant squid was taken only in 2004, the first video in 2012. Before that, it existed as reality only for sperm whales. The giant squid reaches 13 meters in length. Its eyes, the size of a football, are the largest of any living creature on the planet, 30 centimeters in diameter. They are tuned to detect the faintest bioluminescent glimmer in absolute darkness. The flicker of plankton, disturbed by the movement of a sperm whale, gives the squid a few seconds warning. It reacts instantly, with a jet of water expelled from its mantle cavity, launching itself into the darkness. The confrontation between sperm whale and giant squid takes place at depths of 500 to 3,000 meters, in complete darkness, under pressure that would kill most forms of life. No one has ever witnessed it directly. Its testimony is written in scars on the skin of sperm whales, circular sucker marks 10 centimeters across. The squid fights back. It does not yield without a struggle. Sometimes it wins. Bioluminescence in the depths of the Atlantic is not a rarity or an exotic feature. Scientists estimate that more than 70% of all deep-sea species produce their own light. The anglerfish, Melanostus johnsoni, carries a glowing lure on a long filament projecting from its head, a lantern dangling in front of a mouth. Any creature drawn to that light in the absolute darkness finds itself within reach of jaws lined with inward-angled teeth, making escape impossible. It is a trap disguised as hope. The sperm whale returns to the surface. Its blowhole opens with a deep exhalation, a column of vapor in the cold air. It carries within it the nutrients of the abyss and surrenders them to the surface. Every surfacing is a bridge between two worlds. Far to the west, there is a shore, a place where the Atlantic breaks against rock, where the deep meets the shallows. and the most productive boundary zone on the planet is born. Where the Atlantic breaks against rock, a zone begins that rivals tropical rainforests in its biological density. This is the intertidal zone, a strip of coastline that is flooded by the ocean twice a day and twice a day laid bare to the air and sun. Neither land nor sea. A space between worlds, brutal and extraordinarily generous in equal measure. The creatures that live here face a challenge that any engineer would call unsolvable, survive in conditions that change completely every 6 hours. Total submersion in salt water. Total exposure. Wave impacts carrying pressure of several tons per square meter. The heat of midsummer. The frost of a winter night. For most organisms, a single one of these factors would be lethal. Here, they all occur simultaneously, and yet life is here, in every crack, in every rock pool, beneath every stone. Atlantic herring gather in shoals, numbering several billion individuals. This is one of the largest assemblies of vertebrate animals on the planet. When such a shoal moves near the surface, it is visible from the air. A dark, pulsing cloud beneath the water, shifting shape with a precision that would put a ballet corps to shame. This phenomenon, a murmuration beneath the waves, has no leader, no commander, no orders. Each individual fish responds only to the movement of its 7 nearest neighbors. From these simple local rules emerges a complex collective behavior that baffles predators. No shark, no tuna can fix on a single target within a shimmering, unstoppable mass. Herring is the foundation. Everything rests on it. Puffins, gannets, seals, dolphins, large tuna, sharks, white-tailed eagles. Remove the herring, and the entire structure of the coastal ecosystem collapses. It converts plankton into accessible energy. It feeds everyone. Off the shores of Newfoundland, Iceland, Scotland, and Norway, millions of puffins gather in colonies. This bird defies nature twice over. It flies like a bird, swims like a fish, and walks upright like a penguin. Underwater, the puffin rows with its wings, not its feet. It literally flies through the water, reaching depths of 60 meters in pursuit of fast-moving fish. Its beak is a subject of study in its own right. Outwardly comical, it is lined with rows of backward-facing spines on the palate and tongue. This allows the puffin to hold fish already caught while opening its beak to catch more. The world record stands at 62 fish held in a single beak at once. This is not a metaphor for skilled hunting. It is a feat of mechanical engineering shaped by millions of years of selection pressure in a world where every dive comes at a significant energetic cost. The gray seal hauls out onto land to rest and breed, and returns to the water to live. Its diving physiology is a marvel. The heart slows from 150 beats per minute to 4. The diving reflex, reducing the oxygen consumption of the entire body. Blood saturated with myoglobin becomes a reservoir, sustaining the brain and heart while the lungs are empty. Non-essential organs shut down. Only what is strictly necessary remains active. This is not an adaptation to the environment. It is a transformation of all physiology. Every dive is a small death from which the seal returns. The gray seal bridges the deep and the shore. Its excrement, rich in nutrients, fertilizes coastal waters, just as the whale fertilizes the open ocean. Its body, when it dies and sinks, feeds deep-sea communities for years. Nothing is lost. Everything becomes something else. Here, at the boundary of water and land, all the threads of the Atlantic converge. The warmth of the Gulf Stream, carried from the tropics, nutrients raised from the abyss, energy that passed through plankton, fish, and seal, and returned to the water. The Atlantic does not separate the shore from the deep. It connects them. It connects everything. The Gulf Stream carries warmth to where? Without it, there would be only permafrost. The humpback whale fertilizes waters without which plankton could not produce oxygen. The great white shark shapes the behavior of everything that moves around it. The sperm whale carries the abyss to the surface, and the surface to the abyss. Hydrothermal vents prove that life does not need the sun. The Sargasso eel connects the rivers of Europe to the middle of the ocean with a thread 3,000 kilometers long. Herring converts plankton into energy for all. The gray seal dies and feeds those it never knew. There are no incidental details here, no redundant participants, no species that can be removed without consequence. Each one is a thread, and every thread holds the entire fabric. The Atlantic is the youngest of the great oceans. At just 106 million years old, it is an infant by the standards of the planet. It is still growing, still expanding, still shaping itself. And while it does, it shapes the climate, feeds continents, regulates the atmosphere, and creates new forms of life in the darkness of its own depths. It breathes. And while it breathes, so do we.